If you are not able to already share, I'm going to make certain that you can. Yes, should
Okay.
not be a problem.
Okay, can I start to screen share?
Yes.
Okay, so I will start. So it's okay if I begin. Let me see. Here's the workshop. Okay, let me see. Let's see if I put it in. How come it's not coming up? Let's see if I can. See if I can find my little icons here at the bottom.
Yes.
There we go. Okay,
yes.
Now I can put it in the there. Now, can you see that?
Yes.
Okay, very good. And that's not my first slide. Here's my first slide. So again, I want to thank you, Logan, and the Agronomy Graduate Student Association for inviting me to speak in your spring 2021 workshop series on scientific writing. And I'm going to be talking about writing and reviewing for peer-reviewed journals. And again, I want to thank Logan for inviting me on the Committee on Scientific Writing to speak today. And Logan asked me specifically to talk about my personal style and techniques when writing for peer-reviewed journals, and then my experiences both as a person being reviewed and as a reviewer. So let's take each of these topics in succession. First of all, my personal style and techniques when writing for peer-reviewed journals. And I learned from many people, and I just want to focus on a few. My father, who was a professor of physics and agronomy at Iowa State University. My mother, who was a professor of English at Iowa State University. My co-major advisors at the University of Wisconsin, both for my master's and PhD, Gerald Gerloff, who was in the Department of Botany, and Wilfred Gardner, who was in the Department of Soil Science. And then another important person who taught me was Eileen Schofield, who was an editor for the Kansas Agricultural Experiment Station in my early years here at Kansas State. And then finally, I want to mention Betty Klepper, who was a USDA scientist. And when I mention her, I'll state that she was a pioneer in studying plant and soil water relations. First of all, my father, here is advice he gave me. First of all, he says, be exact. Don't call an apple an orange. Use the same terminology for every parameter, even if it means repeating the word. Write in simple sentences. Your publications are going to be read by an international audience, and English is a second language for many, so keep the English simple. Now, from my mother, she taught me to write in grammatically correct sentences, and she also taught me how to diagram sentences. You should be able to diagram any sentence to give the following: the subject, the verb, which is also called the predicate. The predicate is a more general term for a verb. It includes any modifying phrases for the verb, the object, the adjective, and the adverb. And the next slide, I'm going to show you diagrams of sentences. And the diagram, the information I got is from a textbook that my mother used when she was teaching at Utah State University in the late 1930s. And she met my father there, and she had to quit her job as a professor of English at Utah State after she got married because of nepotism rules. But in any event, we're going to see how to diagram a sentence. And in the diagram, note the subject, the predicate, which I said is a verb, the object, the adjective, and the adverb. So here we have the diagram, and up here I give the reference. I've typed it in. So here are diagrams. Whoops. Here, the first diagram, the sentence is the man wants money. So the subject is the man, the predicate of the verb is wants, and the object is money. And then we have a modifier, the man wants money. All right, here is another sentence. The man is a miser. Man is a miser, means he's penny pinches. Okay, so here the subject is man, the verb is, and the predicate noun is miser. And we have a modifier here, the, and a modifier here, Now here's a little more complicated sentence. The pretty girl sings sweetly. Girl is the subject, sings is the verb, and sweetly is the adverb, how she sings. And then we have an adjective, pretty, and then the. And then we can go on to more complicated sentences. So whenever I see a sentence, I think of a diagram. What's the noun? What's the verb? What's the object? What's the adverb? What's the adjective? And so on. So think of these diagrams when you look at sentences. And when I've told students about diagramming sentences, they found it very helpful. All right, from my co-major advisor in the Department of Botany, Gerald Gerloff, he told me to edit, edit, edit. You can't edit enough. And when your edits make changes back to your original version, stop editing. You're just going back to the original. If there are mistakes, reviewers think your science is not sound. Each part of the paper should be of about equal length. And I'm going to get back to this later on in this talk. That means that the introduction, materials and methods, results, and discussion, each one of those parts should be about equal length. And then my own observation is that I find it necessary to proofread from a hard copy. I can never catch mistakes when I read them on a computer screen. So I always print out my papers, and I have a ruler, which I have right in front of me, and I put that ruler and then I proofread each line. I read one line and then I pull the ruler down, read the next line, proofread every single word. All right, my other co-major advisor, Wilfred Gardner, he said, in the first sentence of the results, give the most important finding from your study. So this is one of the most important sentences in your paper, the first sentence of your results. And later on, when I talk about abstracts, I'm going to talk about the conclusion of an abstract, which is the last sentence in the abstract. And that is another very important sentence in your paper. And then also, Dr. Gardner told me, when you submit your paper to a journal, just say, permission is requested to publish X, give the title, by Y, give the authors, in Z, give the title of the journal. Don't go into a long song and dance about how your paper is advancing knowledge, what new parts it has. Usually just the editor or the person who receives the paper is going to see that. The reviewers aren't going to see it. So just don't go into a lot of description. Just say permission is requested. All right, from Eileen Schofield, I learned the following. As I mentioned, she was an editor for the Kansas Agricultural Experiment Station from 1982 to 2001, and she retired in 2001, and she's now living in a suburb of New York City. So your conclusion can repeat your abstract, almost word for word. Whatever's in your abstract can be in your conclusion. And do not bring in new information into your conclusion. Your conclusion should only have information that you've discussed in the text of the paper. That is in your introduction, materials and methods, and results and discussion. Don't bring any new information into the conclusion. All right, here's information I learned from Elizabeth Betty Klepper. She lived from 1936 to 2018. She died just right before the meetings, the ASA meetings in 2018. And she was a plant and soil scientist with the USDA. She spent her last years working in Pendleton, Oregon, and then she worked in her early years at Auburn University in Alabama. And she was a pioneer in root studies, and she was also a woman pioneer in science. She was the first woman fellow of the Soil Science Society of America in 1985. She got fellowship, and she was the first woman president of the Crop Science Society of America. And my pictures over here at the right are sort of cutting off the year. I think it's 1997 or so. Anyway, do not be afraid to send your paper to a journal. That was one piece of advice she sent me. We always keep revising. We're afraid to send it off to the journal because it's not perfect. But just say, this is the paper, this is what it is, and send it off. And then this is a good piece of advice for me. If you don't believe in your own work, no one will. All right, here are some of my techniques when I start to write a paper. Before you start any experiment, consult with a statistician to make sure your experiment is properly designed and can be analyzed with valid statistical techniques. You don't want to do a whole experiment and spend weeks, months, sometimes years doing an experiment and then find that you don't have the proper statistical setup so it can be properly analyzed statistically. So make sure your experiment is statistically replicated properly. And during the experiment, keep careful notes and always keep a hard copy of your data in case computers fail. And use a bound notebook to record data. I always have my students go to Staples or someplace and buy a bound notebook. Do not use loose sheets. Loose sheets get blown away in the wind. A lot of times students have sheets on a clipboard and then they shift the sheets and then they get blown away. Don't do that. Have a hard copy bound notebook and write in pencil, because in rain in the field or water in the greenhouse, ink smears. And if your ink smears, you can't read your data. Keep this bound notebook for several years in case anyone questions your original data, and that might happen. All right, get data in tables and figures, and each table and figure needs to show some measure of statistical variability, and make sure the tables and figures are clear. In my class this semester, I decided to give a few words on how to prepare good figures, and I gave some examples of poor figures, and I'm not going to go into that, but your figures and tables are really important in showing your publication to the audience that's going to read it. And I can spend a long time on tables and figures. Even after I've done the experiment, I check every single value to make sure it's right, and then I spend a lot of time making my figures so they're clear. All right, then after you've done your tables and figures, write materials and methods. This is probably the easiest part to write because you know what you did. And be complete. Give location. You need to give the whether it's done in a greenhouse, growth chamber, or field. And by the way, this needs to appear in the abstract too. You need to know where the experiment was done. And give exact environmental conditions. In the field, give temperature and rainfall. And in a greenhouse and growth chamber, give day and night temperatures, light regime, hours of light and dark, light intensity, relative humidity, and pan evaporation rate. Now, a lot of people don't get pan evaporation rate, but this is a simple way to understand the evaporative demand of the atmosphere. You just take a pan, a pie pan, and fill it with water, and then put it in your growth chamber or in your greenhouse, weigh it every day, and then you can get the evaporation rate from the pan. You know the area of the pan, you divide it by the weight, and then you can get evaporation rate, for example, in millimeters per day. You give the full name of soil, and both the common name based on the soil triangle and the scientific name based on either the USDA or FAO classification system. And some journals, like the Soil Science Society of America Journal, will not accept a paper unless you give its scientific name. Give exact methods with references, and you need to give the model numbers of instruments and give the names and full addresses, the city and state of the manufacturers. Just don't say Sigma Aldrich, USA. Give Sigma Aldrich, St. Louis, Missouri, USA. So give the full address. And give exact dates. You need to give exact dates of planting, harvest, and dates of measurement. Dates are important for greenhouse experiments because growing plants in the winter is different from growing plants in the summer. Then write the results. And as noted in the first sentence of the results, give the most important findings from your study. When referring to data in the tables or figures, give the exact values. Do not have a value, say, of 18.3 grams in a table, and then say 18 grams in the text. The reader cannot find it in the table. Be exact. Say 18.3 grams in the text if that's the value in the table. Then write the introduction. Write introduction after writing the results because they may be unexpected and they need to be addressed in the introduction. I've done several experiments where I've gotten surprising results, so I've had to change my objectives and write the introduction accordingly. The introduction needs to be specific. Do not talk in generalities, and cite literature that is relevant. State how your work advances knowledge, state the objective, and recently journals want you to state your hypothesis. However, I do not think that an hypothesis is necessary to state because sometimes you don't know how the results are going to turn out. I've done experiments where I just have no clue what might happen. I really don't have any hypothesis, but I do have an objective. So always state that objective. Do not limit your literature search to recent years. Look at the old data. Old data often are not known because they have not yet been scanned and put in computers. Rarely is something studied for the first time. If you know the old literature, you know if someone is repeating work already done. Go to libraries and get hard copies of these old journals that do not have the old literature. And if you can't get the journal through, say here at Kansas State University, you can ask Interlibrary Loan over in Hale Library to get copies of the papers. And then they can locate a library that does have this old journal, and then someone at that library has to get that journal and physically scan it, and then you can get the scanned article. And then finally, write the discussion. Sometimes results can be combined with discussion to avoid repetition. In the discussion, do not discuss parameters that you did not measure. Discuss only your results and relate them to values in the literature. Do not say for the first time, as that raises a red flag. Science is incremental. Each new paper makes a small step in the advancement of knowledge. Rarely does a paper report results on a topic for the first time. Now, here are my experiences as the person being reviewed. This is the most difficult part of being a scientist. One has to be thick-skinned. The comments from the reviewers can be the cruelest cuts of all. Here I've spent maybe a year doing a paper. I've done the experiment. I spent all this time preparing the paper, proofread it, done everything I can to make an absolutely perfect paper, and I submit it off to the journal, and then I get these cruel comments. I was able to get my first papers published with my co-major advisors at the University of Wisconsin, that is Wilfred Gardner and Jared Gerloff. But then when I started to publish on my own and put my entire name, Mary Beth Kirkham, as the name had appeared on the publications I did at Wisconsin, I put my whole name down. And my first 3 papers were rejected. Then I resubmitted them with the name MB Kirkham, and they were immediately accepted. Since then, I have insisted that all my publications appear only with my initials, and one cannot see a picture of me on my departmental webpage. I only have a picture of one of my books. There's still discrimination against women in science. Even though administrators now say there's no discrimination, there still is. If a paper is rejected, I consider the comments of the reviewers. If I think they are valid, I revise the paper accordingly. I revise the paper immediately. I stop everything to revise the paper. Of course, I continue on with urgent needs like teaching my class, but everything else stops and I revise the paper. I have a rule where I resubmit the paper to another journal within 24 to 48 hours. I get it back in the review process immediately. And I never protest the decision of an editor. Never, never, never protest a decision of an editor. It only makes the editor mad. Submit the paper to another journal. You will find the right outlet. And back when we didn't have computers and published our papers in hard copy journals, I used to keep a paper file with outlets, the journals being published in my area of research. Now there are hundreds of outlets on the internet. These are electronic journals only with no hard copies. But never submit your paper to a predatory press. And I'm going to say a few more words about predatory presses momentarily. There are enough legitimate presses to submit papers to. Do not forget the journals published by societies, even though many of them are now being taken over by commercial publishers, for example, Wiley, Elsevier, and Oxford. The journals published by the American Society of Agronomy, the Crop Science Society of America, and the Soil Science Society of America, which used to be called the Tri-Societies, all those journals are now being published by Wiley. The society publications cannot compete with the commercial publishers. The commercial publishers allowed you to, or do allow you to publish papers with no page charge. And when we were with the Crop Science Society of America, for example, all the Tri-Society journals had to charge page charges. And I think that the fact that these commercial publishers are taking over our publications endangers the futures of societies because they depend upon publications for revenue. And I know from personal experience, I was chair of the Budget and Finance Committee of the Crop Science Society of America for 6 years. And I know that the publications are extremely important for our financial viability. Publications bring in about half of our revenue. The other half comes from the meetings. And since we now are turning our publications over to Wiley, I really worry about the longevity of some of these societies. As noted, never publish your paper in a journal published by a predatory press. Predatory presses to avoid are MDPI and SCIRP. MDPI stands for Multidisciplinary Digital Publishing Institute, and SCIRP stands for Scientific Research Publishing. Both presses have appeared on Jeffrey Bial's list of predatory publishers. And I might say a few words about Jeffrey Bial. He was a librarian at the University of Colorado in Denver, and in about 2008, he started to list predatory presses, and he has a whole list of reasons why a press is predatory. And then in 2017, a case was brought forth by Frontiers Media, and Bial then withdrew his list of predatory presses from the internet, and the case was closed with no findings. The predatory publishing is an exploitative academic publishing business model that involves charging publication fees to authors without checking articles for quality. They accept articles quickly with little or no peer review. Since Bial's list has been withdrawn from the internet, other lists have since been developed, and some are based on the original listing by Bial. I want to give my personal experience. I reviewed 2 papers published by MDPI. They were poor papers, and one paper had information that was not true. The text said that the levels of heavy metals in soil around a mine were not toxic, but the data in the table showed they were highly toxic. For example, in an average soil, we might have 10 parts per million lead, and in the tables, the levels of lead showed the soil to have like thousands of parts per million of lead in them, and the same with cadmium. The tables just showed extreme toxicity in the soils. MDPI later sent me the published papers, and they had the original version with no revisions made according to my comments. I shall never review for MDPI. My time as a reviewer was being wasted. More seriously, though, was dangerous information was being published. The authors were saying in this paper that plants could be grown in the soil around this mine with no problems, but obviously plants would be highly polluted if they were grown in the soil around this mine. All right, here are my experiences as a reviewer on the other side. Here is how I review a paper. I print out a hard copy of it. Again, I can't read on a computer screen. I just have to read the hard copy. I start my review by writing the title, the authors, and my addresses of the authors on my comments. So I say comments about, and then I give the title, then I give the authors, and then I give their addresses. And this way I learn about the people doing the science and where they are located. If there are mistakes in the title, the way the authors are listed, or the addresses, I already think I'm going to reject the paper. And the title should not be a sentence, and for the reason, see this paper. This is an old paper, but it still is valid. It was written by Judah Rosner, who is a molecular biologist for the National Institute of Health in Bethesda, Maryland. And he entitled his paper, Reflections of a Science as a Product, and it was published in Nature, volume 345, and it was just 1 page long, page 108. The subtitle to his paper says, "A new form of title for scientific reports, one which confidently asserts a conclusion rather than implying it, is becoming more prevalent. That's a bad thing. A sentence for a title says that the results are true forever, but science is always changing, so the results might not always be true. Lay publications often use a sentence for a title, and authors do not want their refereed, serious scientific paper considered as a lay publication. Also, a sentence for a title trivializes the results and reduces them to 1 sentence. Authors find out more than 1 sentence in a paper. And this is my own observation. In addition to these reasons, I think it shows hubris on the part of the authors to give a sentence for the title. Hubris means arrogance, and I don't think authors should show arrogance. I read Rosner's paper again right before this talk, and he reviewed publications in biology going way back. The first paper he looked at was in 1514, and then the last paper that he looked at was published in 1968. All those early papers did not have 1 sentence for a title. And then a sentence for a title started in about 1970, and they became really prevalent about the time he wrote this paper in the late 1989. And he thinks that authors are putting titles for papers in order to get grant money. They can say, I found this, so give me some grant money. And he relates it purely to this need to get grant money. All right, then after the title, I read the abstract. The first sentence of the abstract needs to give the rationale for doing the study. If the authors give me no rationale, again, I think I'm going to reject the paper. Sometimes papers start out saying a randomized block experiment was done studying X cultivars using X rates of fertilizer. Okay, well, why did they do it? Why did they study these cultivars with these rates of fertilizer? Give me a rationale. That first sentence is very important in the abstract. An abstract needs to have the following components. It needs a rationale, objectives or hypothesis, methods, results, conclusion. In the methods of the abstract, the common as well as the scientific name of the plants need to be given, and also the common and the scientific name of the soil need to be given. In the results of the abstract, exact values should be given. You just shouldn't say the plants under a certain treatment grew taller than the control plants. Give me the exact value. What was the height of the plants under the treated conditions, and what was the height of the plants under the control values? Give me exact values. And then again, the conclusion is the most important sentence of the abstract and the message of the paper. Oftentimes when I read an abstract, all I read is just that last sentence. And so like the first sentence of the results, where you give the most important results of your paper, this last sentence of the conclusion is a very important sentence. Concerning the text of the paper after the abstract, as noted, each part of the text should be of about equal length. That is, the introduction, materials and methods, results, and discussion should be of about equal length. Many times I read a paper with results that may say be 2 pages long, and then the discussion goes on and on and on, say 10 pages. The authors are turning their paper incorrectly into a review when they write these long discussions. The authors should discuss only factors that they measured in the paper, discuss relevant data, and not bring in factors that they did not measure. In reviewing, I look for the same things that I put in a paper. Are the relevant papers cited in the introduction, or is it just a review of well-known general information? A lot of times introductions just have general information. For example, there might be a paragraph talking about climate change, or there might be a paragraph talking about how the population is increasing. We all know climate is changing. We all know the population is increasing. These should not be rationales for doing the work. And then materials and methods must include the following, and this is what I put in my own papers: exact dates for the procedures used, dates of planting and harvesting, and dates of measurements. The environmental conditions must be given. In a field experiment, rainfall and temperatures must be given. In a greenhouse experiment, temperature and relative humidity must be given. In a growth chamber experiment, temperature, relative humidity, light intensity, and light regime need to be given. And at the end of materials and methods, it needs to state how the data were analyzed statistically. And the following needs to be given: the experimental design, the number of replications, what a replication is, and what the control is. And by what I mean by what a replication is, sometimes a replication might be one plant in a pot that had several plants, or it might be the whole pots themselves, or it might be 3 measurements made on 1 test tube. What is a replication? You need to know exactly what a replication is. And then a reference to the statistical methods needs to be given. For example, a statistical book, or in the case of SAS, the version of SAS that's being used, and the full citation for SAS, giving its address. And of course, I think we all know that SAS is located in Cary, North Carolina, but give the full address for SAS. If any of this material is missing from the introduction or materials and methods, I stop my review there. I do not review results of the discussion. I cannot evaluate a paper if I do not know the procedures or statistical design and replication. I then look, even though I stop my review there, I do look at the tables and figures. Oftentimes the data are few. They are based on minimal observations. Some authors use indexes or factors to augment their data. These are indexes or factors, and they're manipulations of original data, and an interested reader could calculate them. For example, a lot of times in looking at heavy metals or trace elements, we talk about a translocation factor, and that is dividing the concentration of an element in, say, the grain, divided by what it is in the roots, translocation factor, and those data should be already given in the paper, and the reader then could calculate those factors themselves. Authors often give correlations. Correlations do not explain mechanisms. Explanations of mechanisms need to be given. If there are few data, then I reject the paper because valid conclusions cannot be made with minimal data. Every table and figure needs to be self-explanatory, so a reader does not have to refer back to the text to understand them. So all abbreviations and tables and figures need to be defined in the captions to them. I look to see if the authors editorialize. This often means that they have used an adverb. Words such as clearly and obviously need to be removed. For example, the authors might say, the data clearly show, but this may not be evident to the reader. So the word clearly needs to be removed. Good papers are a pleasure to read and I learn from them. However, a good paper takes a long time to review. I need to check every sentence to make sure it's correct. I must make sure the authors are not making conclusions beyond what their data are valid for. For example, if the authors are studying wheat and in their conclusion they say the results are valid for crops, this is not right. They need to state that their results are valid only for wheat. If there are parts of the paper I cannot review, for example, the mathematics or the genetics, I need to state this. So I tell the editor when I review a paper that there are certain parts that I cannot review. I review a large number of papers every year. I think it is the only way to keep science free from mistakes. Many scientists are encouraged by administrators to focus on getting grants, so scientists refuse to review papers. There's no reward for reviewing papers. When hard copy journals used to be published, reviewers were cited at the end of the year in a list of reviewers, and one could put the citation on one's annual evaluation and get credit for it. This no longer happens. I also review to keep good relations worldwide. Scientists have common goals, no matter in what country they reside. Scientific cooperation is a way to bring about world peace. For example, I'm on the editorial boards of 2 Pakistani journals, the Pakistan Journal of Agriculture Research and the Sarhad Journal of Agricultural Science. I also review frequently for the Egyptian Journal of Agronomy. It's important to help scientists in these developing countries advance their science. Okay, Logan asked me to speak for about 30 minutes, and it's about that time. So I'm closing, and we now can discuss. Again, I want to thank Logan, Simon, and the Committee on Scientific Writing Workshops for inviting me to speak. I'm honored that I have been chosen to speak at this workshop, and I thank you very much for the invitation. So now I'm going to stop share, and maybe Logan, you can moderate if there are any questions or comments.
Yes, absolutely. I invite all of our participants today to go ahead and turn on your video and microphone and ask your questions directly. Additionally, you can put them in the chat and I will read them out and direct them to Dr. Kirkham if you do so choose.
Yes, I do, please, because I don't have my chat on. Okay, good.
I have a question for you.
Hi, Kaylin. Yes,
Hi.
go ahead.
I have my research where I have a lot of variables that I'm going over, over 10, over 15. When I'm trying to write my literature review and the introduction to my paper, my chapter 1, or take on trying to cover all of those variables, or maybe pick a few that I think would be the most important. When there's over 15 variables, how do you think a person should choose what to cover in their literature review?
Well, that's a difficult question to answer. I would think that you might be able to focus on the variables that you think are going to be the most important and focus on those. And then, well, first of all, you need to make sure that no one else has done your work. One of the first things I do is when I get a paper to review, I check the internet, you know, what are papers on this topic? And you go and check and see, well, has anyone else done this experiment looking at all these variables? And make sure that the reviewer isn't going to see those papers immediately when they review the paper. But I would focus on a few important variables and then just say that you can't review all the variables, but you will present data for them in your paper. And just be upfront about it. Just look at a few variables. What are you looking at? What's your study?
I've got an on-farm survey of management practices in alfalfa, which
Oh,
we're trying to see what is impacting yield with management practices, and also how much of that is water to try to close the yield gap in alfalfa in dryland, Kansas. So I've got over 25 questions on my survey, which they all turn into variables or multiple variables. So trying to encompass that all in my literature review has definitely been a challenge in picking what I want to focus on.
yes, indeed. I can understand that. I think that in your write-up, you should give the survey as an appendix or something like that. And I don't know, 25, it seems to me that you might be able to list what those variables are in your introduction, and then just look at, review information where people have done other surveys. I don't know if you can do that or not, but then just say that as I say, it's a difficult thing to look at, but it seems to me your paper is a survey, so you need to focus on survey methods, and then look at other surveys that might have been done on this, and then maybe just briefly mention all the variables. You really can't, you're going to have to, you're not doing an experiment yourself, looking at the effect of water and all these other things yourself. You're looking at the survey. So you have to review the survey method rather than what exactly the people are answering in the survey. I know that's sort of a complicated answer,
That's
but
okay. I knew it was going to be complicated when I asked it. So
yeah, yeah. But if you, I don't think it'd be appropriate in your literature review to talk about the effect of water on alfalfa or all these other things. You need to talk about the survey itself, and then present the survey and your methods, and then the results of the survey.
awesome. Thank you.
You're welcome.
I have questions, but I don't want to hog the floor. I want to give other people the chance.
Sure, right. Sounds like we have a quiet group today.
Yes. I guess I will ask one question. You talked about the importance of reporting the environment that your experiment took place in, whether that be a greenhouse, growth chamber, or in the field. Have you ever, as a reviewer, have you ever read a paper and thought that they're trying to maybe mislead the reader into thinking that they were doing their experiment in an environment that was not correct? So, like, for example, I'm thinking of two examples. I've read papers where they implemented their study in a greenhouse, but they did not make it clear whatsoever. It could have been interpreted as taking place in the field. And then there was another one where I encounter they will present their research in the field, and what they will not state is that it was under irrigation. And so they make it appear as if they are making this great headway under dryland or rain-fed conditions, when in fact this was conducted under irrigation. Have you
Yeah.
encountered that?
Definitely, I encounter those situations quite frequently, and that is why in your abstract you have to state exactly where the experiment was done, and then also repeat it in materials and methods. Where was it done? And then also I have the same problem, particularly with some of these papers from the Pakistan journals, that some places they just routinely irrigate, and I don't know that. So they need to state what the irrigation regime was, and a lot of times in the papers I review, they don't give the exact amounts of water. So you need to give the exact dates of irrigation and the exact amounts of water, and definitely state whether or not the crops were irrigated. Yes, so those are common problems, and that would be a reject if the people didn't, or at least, modify. it's something that you have to do in their revision. Yeah, and that's why I find I didn't say anything about fraud, but that is a big problem in science these days. And the paper I mentioned from NDPI was just misrepresenting the data. I don't know if it's fraudulent or not, but I think when you ask for specific dates, you pin the author down. They're just not manufacturing data. They have to have dates when they collected that data. So I think that's one way to make sure the data are valid.
Thank you. Yes, I just occasionally, and there's a few that do this regularly, not in Kansas, and I won't name their name, but they will present data for their experiments in a dry region, and they will only very briefly, maybe one sentence in the methods, oh, yeah, we irrigated.
Yeah, well, that's not right. They say they need to give the exact amount of water and when they added that water. Yeah, that's misleading the reader.
I had another thought too. You talked about reviewing the older literature. I think that sometimes we have a pressure to review relevant data, and sometimes relevant gets misconstrued as recent.
Yes.
And so you're exactly correct that we need to be reviewing the older data. And I really love the way that you stated it, especially today in 2021. We are never the first person to look at something. It has been done before. And like you say, research is incremental. The number of breakthroughs in 2021 are very few. What would you recommend for graduate students, how they can access that information? Because sometimes it seems very inaccessible.
Yes, it is inaccessible. And then also just getting references to some of those early papers. You have to really dig back into literature reviews to find some of these early data. And I've just been around a long time, so I know some of the early data, and people today just have completely forgotten about it. So experiments are being repeated that were done years ago. The best way to access these data, as I say, is we do have a lot of old journals here at Kansas State University. They're in storage out near the airport. And so if we do have the journal here, the library will let you know. And then someone can go out to the airport, or, well, not the airport, but this building. I don't know exactly where this building is, but it's out there someplace. And get the journal and scan the article that you want from it. But some of these, like a lot of the early scientific literature, comes out of Germany, and so some journals might be in other countries, and so Interlibrary alone then has to find where this journal is and then ask them to scan it. And when I've done that, a lot of times the person who scanned the article hasn't really done a good job, so the edges might be missing, and you got to make sure that you have a good copy. But that would be the only way I know how to get these old journals.
Okay. We got a thank you from Kinda.
Yeah, I guess he's leaving us. That's fine. Thank you. Right.
Yes.
I have one more question for you.
Yeah, sure.
How much time should you spend on variables that did not have, that were inconclusive? How much time do you spend there?
I would just spend relatively little time on that, and just say in passing these variables were not significant. Again, to get back to your question about surveys, I had a student several years ago who did a survey of high tunnels in Kansas, and high tunnels are big hoop houses where plants are grown and to extend the season. And she went all over Kansas and did a survey of that, and she had a series of questions where she wanted to know how long the hoop houses had been used, the soil under it, all sorts of things that she asked in the survey. And she did have an appendix, I think, where she gave the survey, But I think in our introduction, we just mentioned the importance of hoop houses and how the surveys on them had not been done. So I think in your literature in introduction, you need to talk about all these variables that do affect alfalfa growth, but that no one has actually done a survey of farmers in Kansas to find out what's important to them. Just focus on your unique aspect. And maybe there won't be a whole lot of literature that you can cite in your introduction.
Yep, there's like nothing for alfalfa surveys out there, so definitely something new, and it's perennial. So the only other one on a perennial crop that I know of is an oil palm. So that's a big paper that I've been citing. But other than that, it's been done on corn, soybeans, and wheat in the Western Corn Belt. But other than that, nothing perennial. So it's definitely a new thing.
Yeah, well, just cite those papers, and then your introduction, it sounds like it's gonna be pretty short. Yeah, but again, I think you're not about telling about how the soil affects alfalfa growth or how the water affects alfalfa growth. That's a separate experiment. Your focus is on the survey.
Okay, thank you so much.
Well, thank you, Kaylin. Good luck.
A thought comes to mind from the first thing that Kaylin said. Sometimes I think that non-significant data sometimes does not get reported.
Yes.
And the problem that I see with that is that we can misinterpret to believe that something always has an effect when in fact it was only the 25% of the time that it had an effect that was ever published. And so 3/4 of the time it does not affect it, but we would not know that.
Yes, and that's one of the big problems in science, that people do experiments and then don't get results or neutral results, and so they don't report it. There was a while back where there was a journal that was reporting neutral results, and I don't know what happened to it. It's very hard to get a paper published when you can't get any results, but it would be important to report those data in a paper. And then, of course, theses, which the Parker Memorial Library, and I'll put a plug in for it. We have all the theses that were ever published in our department up in the Parker Memorial Library, and theses will report data that are just neutral, where there was no result or that the treatment had no effect. So I do recommend looking at theses too, and not just the published literature.
Fantastic. Okay.
Well, it sounds like we're a pretty quiet group. I'll be
Yes.
glad to help anyone. If anyone wants me to read through drafts of their papers or anything like that, I'll be glad to comment on them.
Yes. And a final plug for Agronomy 820, Plant Water Relations. If you've not taken that class before, you are totally missing out. Plan to enroll next spring. It will be your favorite course you've ever taken at Kansas State University.
Okay, well, thanks a lot, Logan. I appreciate that.
Yeah. Yes. Thank you very much for your time, and thank you everybody for joining us today.
Thank you very much. You all have a good evening. Bye-bye.
Thanks, Dr. Kirkham.
Thank you, Eldaldo. Yes, thank you. Thank you.
Thank you.
Thank you. Bye-bye.
Thank you.